So what do we do if we're just given the values or the data like we are in 19 and 20? Okay, and I was able to download. I don't think you guys are, so you could check. I was just looking at that. I wonder if they've got data file for 20 and it's just not listed. Yeah, exercise 1120, it shows it in here, but it doesn't show it in the book. So you should be able to download that for 20 instead of having, yeah, sure. And that way, less likely to, although, you know what, I have found an error in the download before, but hopefully you're less likely to. 14, 7, 4, 5, 17, 12, 8, 9, looks okay. 2, 7, 3, 6, 8, 13, 3, 5, there you go. Okay, so you can download the data, and it sets it up. It's going to be different direction, you know, than what we did on 17. But it kind of goes back, and again, we're building on some of the things we've done in the past when we're finding standard deviations, means, those things, right? So I've downloaded it, and I might have had to add, you know, the before and after here. It might have been downloaded. I'm not 100% sure, but in any event, it gives me the dollar signs. Okay, or the dollar amounts that they earn. We want to know if it improved, right? If our mean or if their second sample, I guess, is greater than 0, if we had an improvement, basically, okay, or if the mean didn't improve, actually, okay, given the standard deviation and all those other things. So I got to state my hypotheses, and again, I go with my null is that mu1, and that should be d1, isn't it? Okay, d1, or the mean of this, is greater than 0, and my null hypothesis is that it's less than or equal to. If I called that my null, I'm sorry, that's the alternate hypothesis, is the bottom one. And the top one then is my null hypothesis, is that d sub 1. I don't know why I got mu there, because I think it should be d, right? Oh, it's mu sub d. That's what it should be. And I got sub 1. It should be mu sub d and mu sub d. Okay? Well, we go back and we do the old-fashioned stuff that we did. We calculate our standard deviation. We do that by first, well, we calculate standard deviation of the difference. So we simply subtract one of these from the other. Okay, and I think I'm going to go this way because I want to know if it got bigger. Okay, so I subtract the after, or subtract the before from the after. Okay, and then because that's the same, I can just drag that on down. Okay, and then I can do a total of that. I can do a sum of that. And then I can divide that by my n, which was given to me, but I could count it too. I got 12 samples, right? So this is simply equal to my total change, right, divided by my number in the sample, which gives me my kind of average change, basically, is what I'm saying there. Okay. And then I want to know how the difference varies from this change, right, from that mean. So simply equal to, again, this minus that, and I'll hit my F4 there to keep that reference kind of constant, and then I can drag this down. Butamus. Okay, there we go, and then I square that, right? Okay, and I carry that down, boom. I get the sum of that, which is not my variance. Okay, remember, that's not my variance. The sum of that is not. And I don't do the average because I've got to make that adjustment that I make when I've got a sample, right? And so to find out my variance for the sample, it's equal to this sum divided by my n minus 1, and sure, I could do that in my head, but oopsie, 12 minus 1, okay, or 11. And that gives me my variance, and my standard deviation is simply equal to the square root of that. I've got square root, okay? You guys know how to do that. Okay, so now I've got my data, right? I've got my n's equal to 12, my standard deviation is equal to this, and I just need to calculate my t, right? And my d is equal to this one, right? The mean of basically my differences. Okay, So I just simply go, it's equal to the mean of my differences, boom, divided by my standard deviation. I'm going to use parentheses, divided by my standard deviation, divided by the square root, and I'm going to do it the easy way, the square root of my n, which is that. 2.2093. And guess what? I can do the t-test also paired for two sample means, just like I did before. And that turns out to be here. And again, to show you how to do that, I leave this one up here so I know if I did it right or not. Data analysis, t-test paired, two sample for means, okay. My variable range 1 is going to be here, and my variable range 2 is there. I grabbed the label, so I want to make sure my labels is clicked. My significance given to me for mine is at 0.05, and that's what's in there. And my output range, I'm going to bring that to here, I think, just so it's a little bit out of the way. Click OK. See if that, ooh, look at that. How come I ended up with a negative up there and I had a positive up there? That's kind of interesting. And I reject it if it's, ooh, two-tail, but this is a one-tailed test. And my t-stat that I have found, I got to go see why I did that. I'll tell you in a second. There you go. I left them both up so that we can take a look, and the reason is I'm comparing the after to the before. I've got to actually put these in kind of backward. In other words, this is my first one and this is my second one, because I want to know if, you know, if I had improvement, if it is, you know, the alternate hypothesis is if it is greater than, okay. I know this stuff confuses me too, so I'm going to delete that and just kind of fix it here, and then we'll see how that works. Okay, so again, data analysis, t-test. That's why I do the work there, just because now I can tell. So I'm going to do my after first, and then my before. Okay, 0.05 labels. I've got the right spot. There we go. Okay, so my calculated t-statistic is 2.20093. Isn't that amazing how it's exactly the same? I'm going to reject it if it's 1.79. Theirs does get a little bit. Okay, so what do? I reject. I need to put that in there. Reject the null. It is likely the incentive plan was effective, and I got to find my p-value about exactly. About. Is that like an oxymoron? It's about exactly 0.025, which certainly would say, because it's so low, would say that it confirms that was effective, right? So I reject the null, so I'm rejecting this one that it's less than or equal to. I'm accepting the alternate that it was greater than, right? That my mean here was greater than 0, so it was a nice improvement is what we're saying. There you have it, chapter 11.